Hi, today's topic will be integration of sine and cosine function, further indefinite integration and definite integration. For integration of sine and cosine function, first we are going to revise a little bit on what we have learned in differentiation. So when you are differentiating sine of x, you are getting cosine of x. In reverse, okay, if you are actually integrating cosine of x dx, it will give you sine of x. This is the first rule of integration. Secondly, when we are differentiating cosine of x, it is giving us negative sine of x. In reverse, okay, if we are integrating negative sine of x with respect to x, we are getting cosine of x. Hence, if we move the negative over to the other side, okay, we will be getting integration of sine of x dx equivalent to negative cosine of x. Not to forget to plus c for any indefinite integration, plus c. We do not have integration of tangent of x, but since we know that differentiate tangent of x is giving us secant square of x. In reverse, if we are actually integrating secant square of x dx, it is giving us tangent of x plus c. But not to worry, because this particular integration is not in your syllabus. So we have learned about integration of cosine of x equivalents to sine of x plus c. Also integration of sine of x dx equivalents to negative cosine of x plus c. So now let's look at if you are given integration of cosine in bracket ax plus b. Okay, what can you do? So the rule is, when you have to integrate cosine of ax plus b, you will be getting sine of ax plus b. Okay, please remember that the angle don't change. Okay, what to do in extra is, you have to differentiate what is in the bracket. So differentiate what is in the bracket and then divide. So after you differentiate ax plus b, you will be getting an a. Hence, your answer is sine of ax plus b divided by a plus with c. You can also write it in this form, where 1 over a sine of ax plus b plus with a c. Moving on to next, we are going to look at integration of sine ax plus b dx. Integration of sine will give you negative cosine of ax plus b. Divide by the derivative of ax plus b. Hence, what you are getting will be negative cosine of ax plus b divided by a plus c. Or you can also write your answer as negative 1 over a cosine of ax plus b plus with a c. Next, we are going to look at a further indefinite integration. So we have learned about, if you're given fx, when you differentiate, you are getting f prime of x. In reverse, if you are integrating f prime of x with respect to x, you will be getting fx plus with c. So in this particular topic, they are testing you on how well versed are you knowing the relationship between the forward, which is the differentiation, and the reverse process integration. For example, let's look at this question. So if question asks you to differentiate x ln x, and then hence find the integration of ln x of dx. So the word hence here actually tells you that you must make use of the answer that you have obtained in part A to solve part B. So let's solve part A. To solve part A, let us let y equivalent to x ln of x. So dy dx, in this case we have to use product rule, where we see this as u, this to be v. So product rule tells us that u multiply with dv dx, which is 1 over x, plus with ln of x times with the derivative of u, which is equivalent to 1. So in other words, you will be getting 1 plus with ln of x. That is for part A. To continue with this, okay, since we have this relation, so I can also write it as integration of 1 plus ln x with respect to x will be giving me x ln x. Or I can also write it as 1 dx plus with integration of ln x dx is equivalent to x ln of x. Go back to the question of part B. Question is asking to find the integration of ln x dx. If you look at what you get here, okay, this is the exact part that the question is asking for. So hence, to solve part B, what you need to do is you bring this to the other side, where the next step will be integration of ln x dx equivalent to x ln x minus integration of 1 dx. From here, positive, when you move over, it becomes negative. Solving this will be easy now. So x ln of x minus integration of 1 will be equivalent to x. Lastly, plus c. So that's the solution for part B. We will move on to the next on definite integration, which we have spoke about. This is the integration of function between limits given. So what is limit? As such, if I have integration of 1 to 4 x squared dx, the top number will be the upper limit. Okay, the bottom number will be the lower limit. So we are going to proceed with integration on this, where integration of x squared will give us x to the power of 3 over 3. We need to write the limits, okay, from 1 to 4. The next step is the substitution of the limits in the equation. So first will be 4 to the power of 3 divided by 3 minus 1 to the power of 3 divided by 3. Hence, you just need to solve by using a calculator, where you are going to get 21. So this is definite integration, where you are getting a final answer, and there's only one value without a constant. For example, if you are asked to evaluate, okay, exponential of 2x with the limits of 0 to 1, what you should do is integrate exponential of 2x is giving you exponential of 2x, and then differentiate 2x, which is giving you 2. copy the limits from 0 to 1. The next step that you proceed is substitution of the limits into the equation. First, you substitute the upper limit. So, exponential of 2 multiplied by 1 divided by 2 minus exponential of 2 multiplied by 0 over 2. Hence, here you'll be getting exponential of 2 over 2 minus 1 over 2. Here, because of exponential of 0 is giving you 1 for this particular part. If you want to factorize the equation, okay, what you can do is factorize the common factor, which is 1 over 2, and hence it is giving you exponential of 2 minus 1 in the bracket. That's your final answer. Thank you for watching. Please subscribe to our YouTube channel, Max Department of SJS, for more interesting videos.